Hey there, we're back, and we really hope you enjoyed the work from week 6, looking at some of the uncertainties in democracy, some of the issues around voting, and how we count votes, and how those votes, matter to democracy, and sometimes don't, have an influence. And I think what we're kind of leading into this week is looking at something called spurious precision, sometimes spurious accuracy, and specious precision, and those things are pretty prevalent across society. So I know that 4 out of 5 dentists recommended the toothpaste I used this morning. I think it was Colgate, but then 4 out of 5 dentists also recommend Crest. So I don't know who the 5th dentist is. And what about you? How did
Yeah, and in comparison to what? Right, like they recommend Colgate as opposed to nothing,
Right.
as opposed to another toothpaste. I don't know. It's unclear.
It is unclear. And what's also unclear is where we get some of these numbers from and how not just companies like Crest or Colgate or whatever your favorite toothpaste company is, where seemingly 80% of dentists like all of the different brands, which is, I don't know where the other 20% are residing and why they're actually voting for more than one brand. But governmental organizations also put out a lot of numbers that mean things to us as consumers and as people. So we do see corporate influencing on our health as well. Like, so you buy Lysol wipes or you buy something that promises 99.5% of efficacy against to kill the bacteria in your kitchen, right? So you don't get salmonella. And then the other, brand of wipes, the Clorox wipes or whatever, say 99% effective. That influences your consumer purchasing. And then there's also a whole bunch of health information that's put out by Health Canada, also in the United States, actually globally, really, for things as banal as how much water you should drink in a day or how many
fruits and vegetables you should eat.
How many fruits and vegetables you should eat.
As if 7.5 glasses of water isn't quite enough, but 8 is that magic number.
Right. And 8 hours of sleep. And so one of the other things is what we do with those numbers and where they come from. So we don't know always where they come from. And I think some of the values are not harmful. I don't think it harms anyone to have 5 fruits and vegetables a day, as you can see in the reading, but also how we're manipulated with numbers into believing that if we shortfall those things, we need to change our behavior. And society as a whole is seeking to meet these benchmarks, like getting 8 hours of sleep a night, even though that might not feel natural to you. Now, how is it a wicked problem? Part of it is that what do certain kinds of accuracy do and not do for our psychology as people? So I know I normally take 18.3 minutes to get to work. How long did it take us to get to work this morning?
A little bit longer. There was some snow there. So, maybe 18.73 minutes?
Maybe 18.73 minutes because there was snow on the road. Now that sounds really accurate and it might be expected from us because we work in mathematics and science all day. And you might think these two people are huge nerds that have a mean for how long it takes them to get to work. But I also have a mean for my class averages. And if I say my class average is 85.33%, I look at I not only collect amazing data about my students, but that data somehow has deep meaning at 2 decimal places.
And I was doing some work with my students in a math class, and we were looking at population growth and decline. And so we were looking at the population of foxes and predicting what that population was going to be in the next 4 years or the next 8 years. And, some of their answers were, there's going to be 723.68 foxes, right. As if that 0.68 is, kind of important and countable, but also that very precise number, if we're looking at 4 years or 6 years or 8 years out, it even just to say a whole number of foxes is awfully accurate, where maybe a range of numbers might be more appropriate.
Right. And we often don't accept a range. So if you look up ginormous numbers, how many ants are on the planet, you'll be 5 quintillion. That's a very specific number, and it's a lot of ants, if I might add. But, how do we arrive at that? Well, the best part about really exact numbers is that they're often extrapolated, and they're huge, they're huge estimates, actually. You couldn't possibly count all the ants anyway. And so they're extrapolated data to start with, in the same way that the growth of foxes or the decline of species that are going extinct boil down to a kind of estimate. And so what I'm going to talk about, and I have a little PowerPoint presentation that I'll narrate, for us. And this is not a super long presentation, but we're going to talk a little bit about why ranges versus having very specific numbers might be one way to think about data in society, and actually also how the over-specification of certain kinds of data actually poses a wicked problem. So stay tuned for that. So I'm just going to have a quick chat about spurious and specious precision and why it might be considered a wicked problem. One of the things that I want to do is just introduce the idea that numbers can be spurious. So what does that mean? What it actually means is that we have numbers that are being employed and used in a way that conveys basically fake accuracy. What I like is this quotation by Lawrence J. Peter of the Peter Principle, who says, "Some problems are so complex that you have to be highly intelligent and well-informed just to be undecided about them." And I think we have a problem in society these days about things that we are indecisive about, and also perhaps don't convey enough accuracy for them to be believable. And that's a huge problem in terms of convincing people to act a certain way and behave a certain way and make decisions about their lives, because they're looking for increased data and increased information, particularly in the 21st century, and even more so post-COVID, where everybody's looking for information all of the time about their own health and the things that will influence their own behavior. And they're using statistics to do that. So this is from the website logicallyfallacious.com, and fake precision can be defined here as using implausibly precise statistics to give the appearance of truth and certainty, or using a negligible difference in data to draw incorrect inferences. So that might mean exaggerating small differences. It also might mean using data in fallacious ways. So one of these things that have been exposed over time has been the body mass index, for example. So you see people saying BMI is really inaccurate, and then other people, even physicians, quoting BMI as a relative indicator of health, saying your BMI is too large. And so people like Simone Biles, for example, the famous gymnast, are considered obese according to their BMI because she's really short, but of course extremely athletic and extremely well built. So her body mass to height ratio actually would put her in an unhealthy BMI index, even though she's healthier than probably 99.9% of the people on the planet. So I want to bring up this small example from Daryl Huff, and this is adapted from him. And here's a great little story from the book, How to Lie with Statistics. So it says, suppose you're a would-be statistical researcher and you've decided to write something on how long people sleep. Pretty good data. You're going to talk to 100 people, which isn't a huge number for a study, but things have been published on less data about it, and here's where it starts to go wrong. So for each person you interview, you simply ask them how long they slept the night before, and the responses are looking like what are listed here. Well, I don't know, maybe 7 or 8 hours, about 7 hours, or I was awake for half the night, no more than 5 hours. I'm not sure, 6 hours maybe? No, 7, let's say 7. And then this last person who's, yes, extremely accurate, 7 hours and 20 minutes. So we all know someone in the bunch who's probably extremely accurate about it. So if you were a statistician and you were going to take all this data, you might round it. You might say, well, there's 8 and 7 and 5 and maybe another 7 and another 7. And the mean would be, the median would be about 7. Right? So we could use a statistical measure. You could use the mean as well. Let's say that. But the problem is the nature of human consumption. So saying people get on average 7 hours of sleep doesn't do a heck of a lot for the public. And reporting that doesn't sound statistically significant. And so if you were to add up all the values and you divide, you could get like 7.19. That's 2 decimal places. That's super impressive. It looks accurate. So it has to be scientific. And so we have an extrapolation problem. We think, okay, we've taken all of this anecdotal and personal data, and then we've taken it, up, and we've, let's say, gotten our 100 people, and we have 7.19 as the mean number of hours that people sleep. And it also makes it sound scary if you're somehow outside of that very narrow value or its acceptable range as reported. So the problem with that is we had no way of doing that with the data accurately. Nobody in the study who's using these kinds of phrases like about 7 hours, I don't know, 6 or 7, has given enough accuracy to 2 decimal places for us to report it later as such. So if spurious accuracy results from changing the units of what we're reporting, and so that kind of fictionalization of significance has a huge impact on human behavior. Other instances of spurious precision occur all the time in the news. So an example might be that a sinkhole opened up across a street, let's say, or an urban area, and it's reported on the news to be 66 feet across. Except that that's where does that number come from? I don't think the reporters were there measuring it. And maybe that data is being calculated from a drone or something like that. But in general, what happens in these cases is that there's a sinkhole that's larger than 10 meters and less than 30 meters. So, reporting will take 20 meters and convert it to feet, and that's 66 feet. So you end up with data that's in the news that's reported as being extraordinarily precise when actually it's not, but it gives the illusion of both accuracy and relevance to the viewer. Michael Manelli and Ian Harris have written a book called The Price of Fish, A New Approach to Wicked Economics and Better Decisions. And in this, they actually bring up a really great vignette around the price of fish and in a very specific example. And the example that they used was back in the 1990s that there were rumors that fish stocks were declining, sardine stocks were declining off the coast of Monterey, California. And this actually built up the price of tin sardines, and they became a hot commodity on the market. So like a bubble. And that bubble, created an inaccurate consumptive practice. So like people, didn't like the sardines because they were tasty, and in fact they may not have, but that this bubble caused a huge inflation, which caused then the depletion of the fish stocks, which caused like a crisis. And we've seen that off the coast of Newfoundland. We've seen actual financial implications and environmental implications for prices and speculative mathematics driving up the price of something to the point where it's both expensive and its root, like commodity, in this case fish, is overfished to the point of extinction or near extinction. So the best way to go about problems like this is to understand the importance of something called confidence accounting. And confidence accounting is promoted by Manelli and Harris, where financial statements actually can be delivered in ranges rather than with extreme precise financial accuracy. And so that includes like revenue recognition, tax liabilities, goodwill and intangibles, asset valuations, share-based payments, and management performance fees, and even valuations in the market. And that way you get away from like a stock market propensity to assign exact values down to the cent of particular commodities, causing bubbles like the fish bubble, but also causing other strains in like real ecological issues and real other global market issues, and so flooding the market or causing huge spikes in the stock market. And so confidence accounting could result in finance departments talking about their accounts in ranges rather than using spurious precision to give exact values of what's going on, and that causes more stability. And it also prevents huge volatilities in human behavior and huge volatilities in the actual economic markets. So just to wrap up, I want to have us think about a couple of questions, and those questions will be in the reading module as well. And so one of the questions would be like, what are the ethical issues around autonomy and consent? So the manipulation involved in using spuriously precise numbers can undermine our individual autonomy. Like if I get the feeling that something is better or more accurate based on the numbers on the packaging, or I'm told that the price of a particular stock is going up by tenths of a cent, but it's going to skyrocket by 7 p.m., like I might make a financial decision on that basis. And is that as human behavior being changed by spurious numbers all the time? The other one are, what are the political dimensions of spurious precision? Like, what's the role of the state, like the government, in influencing individual behavior and the balance between responsibility and structural factors in health? So if I'm told that my BMI is much too high, which it might be, here I am on camera, or I'm told that I'm not drinking 8 glasses of water a day and that 6 is not good enough, I might go and change my actual behavior as influenced by something Health Canada put out, particularly if it's in official campaign documents by those government agencies, by Health Canada in particular. And should the government use spurious precision in campaigns, even if they benefit the public? So that's a huge question. And then just to think for yourself, like what are some instances of spurious or specious precision that you encounter in your everyday life? And how do they influence your behaviors or perceptions of data, but also your behaviors or perceptions of reality? Like, are you walking through the world really believing that, you've not made your 10,000 steps per day, so you've fallen short of a particular benchmark that is deemed to be extremely healthy? And do you go out of your way to change that behavior? Like if you're at 9,500 steps, do you put an effort in to get that extra 500? And what effect do you think it has on your health in doing that? Is there a detrimental effect to your mental health that you feel all this pressure because a company like Fitbit told you 10,000 was the magic number? Or do you feel better for putting in the effort and appreciate that a corporation or the government has influenced your behavior, whether it was through the use of spurious precision or not? So these are really important questions to think about. And, I think it'll be wonderful to write about some of those things in your reflections, in your reader response for the week. Thank you so much for tuning in.